on as you guys logging in. Opinion on Algebra 1 is first semester, lines, and then we talk about exponentials, and then we talk about parabolas, aka quadratics. That's our opinion of what Algebra 1 should be. And it's pretty darn effective. So once you go into my page on Nicole, log in there, you're going to see a practice assessment of some sort.
Sample assessment.
What is it? EFS review. I'll take that.
No, that was due in February.
I'm pretty sure it's a sample assessment. Sample assessment.
Yeah, so that's it. Sample assessment.
Ding dong.
Yeah, ding dong. So let's see. Let's take a look. When we're getting, once everyone starts getting in there, we'll kind of walk through some of the problems together. So if I dim the lights, would that be okay?
Yes, it would be awesome.
Yeah.
Okay. I can have my sleeping computer. Of course, mine just had to be one of those.
Yeah.
Why didn't I just let you?
You want us to take this right now?
Yeah, go ahead and go into it. We'll actually kind of walk through it together because I think some of the questions are goofy. So, huh? Yeah, start a new attempt. Yeah. Sample assessment. Yeah. Good morning. You're able to start getting in? Does everybody haven't up yet the actual assessment?
Other questions?
So,
It's loading for me.
so let's see what yours says. Okay. It is. What's in between these?
3x plus 9.
3x plus 9
And then
minus 10 and then
equals negative 4.
equals negative 4 like that?
Yep.
Okay, so I'm still waiting. Once you get in and you start taking a look at this question, I think some of this is just how you can manipulate things around, answer the question. So does everybody have that as your first question?
Yeah.
I just don't know if they had changed anything on it. Okay, so just by looking at that, it's a absolute value equation. That's what the big vertical lines mean. Absolute value means how far away from 0 are you? Okay, so think about this. How would I start solving this problem? I'm going to leave those on for right now. How would I?
Add 10.
Yeah, if I just add 10 to both sides, I'm going to wind up with this.
3x plus 9 equals 10. 6 minus. Yeah.
Is that okay? Anyone stuck on that first primary part? So it's just a way of looking through it. All right, so absolute value, again, means how far away from 0 are you? It's a distance. So think about your linear equation. You have 0 here, you have a distance here, and you also have a distance here. So that means you can have two distances on the x-axis away from this. So what you're going to do is you create this to be two different problems. So your first problem, once you drop the absolute value sign, looks like this. That seems good, right? But your second problem is going to look like this.
Whoa.
So notice there's one sign change. Make sense? Yeah, so the more complex side you keep the same, the less complex sign you change the signs on. So if you solve this, subtract 9, okay, I get that. That's 3x is equal to negative 3. So divide each side by 3, so I get x equals negative 1. There's one solution. Our other solution is I'm going to subtract 9, negative 3. 3x is equal to negative 6 minus 9 is negative 15, right?
Oh.
And then divide each side by 3, so I get x equals negative 5. So I have two different solutions. And the reason there's two different solutions is because, again, we're talking about we have a fixed point. We can go to the right of that point a certain distance, and we can go to the left of that point a certain distance and have the same distance. That's all absolute value means. Okay, so try and make that work for your answers. And I don't know how the problem was set up. Is there a way to drag or a way to answer it?
You just.
Yeah. So if we plug this back in, we do the thing.
If you plug those back into x in the original, it would work.
And then the absolute value just switches the sign.
Yeah, it's always the positive component. Because it's the distance.
So if it's positive 6, so then the distance would be 6.
So is everyone able to plug this into your computer at some point? Once you have submitted your thing, did you go to the next question?
Yeah.
Let's see, which of the following statements are true about linear equations?
Drag true or false. Ooh, this is
Want me to try some?
I'll toss it.
drag it.
So which of the following statements about linear
I'm gonna guess.
equations
And if it's
are
right,
looking up what's true? So true, false, or true? Okay, so it looks like you're answering true or false on. You're answering true or false on those particular statements. Okay? Talk amongst each other and figure it out. Carl's thank you for the tissues.
Thank you.
We can use
We
the
have new
calculator.
tissues up here if anyone needs them. You know, if you can question the shirt for example.
Oh yeah. I've lost.
I totally forgot how to do this.
Isn't it like x1 minus y2 minus y1?
I like to choose.
Oh yeah, you're right. You are very much right.
Corey.
It's y2 minus y1.
So drag the true and the false up to where you think they go.
What?
Linear equations. Equation of passage.
I'm gonna go.
6 over negative. Oh, but it already
All right, what do you think? What does it say?
The first one, the equation of the line that passes through 7, 10, and negative 1, 4 is parallel to the line. Y equals 3/4 x.
Okay, so take those 2 points, figure out the slope. You guys know the slope equation, right?
Y
So if they gave you 2 points, what's the 2 points?
It's true.
10. Yes, Thomas.
7, 10.
7, 10?
Yeah. And then negative 1, 4.
That?
Yeah.
So remember your slope equation is this, the y values over the x values.
Oh,
And so you got 4 minus 10 equals negative 1 minus 7. So that's negative 6 over negative 8, which comes out to 3 over 4. What's the linear equation they gave you?
3/4
3/4
minus
x
2.
Yeah.
What is it?
3/4 x minus 2.
Y equals that?
Yeah.
Cool. So what's the slope of that linear equation?
3/4.
3/4. What's the slope we found here?
3/4.
3/4. Are they parallel?
yes.
I'm not trying to drag.
So how do you drag it?
You just drag it from the bottom. But
It's like not.
the negative
same.
2 back.
Yeah, it's like not.
So that is true.
Yeah, I know.
Corey, I just ripped them.
maybe because it's wrong.
Do you all figure that out? Does anyone need the second one to be gone over?
Yeah, can we go over all of them?
Yeah, what does the second one say?
The equation of the line containing the points negative 1, negative 2, and 1, 0 is perpendicular to the line y minus x equals 6.
Y minus
X
x.
equals, so y minus x and then equals.
Y minus x equals 6.
Yeah.
Okay.
That's true.
Cool. So on. All right. So perpendicular. What do perpendicular slopes look like?
Like this, right?
Whoops.
Right angles.
I think my computer's like.
They make right angles. So remember your slope equation is this. Oops. Y2 minus y1. Excuse me. Over x2 minus x1. So let's do this. Go 0 minus minus 2. 1 minus minus 1. So that's going to be 2 over 2. So that equals 1. So a perpendicular slope. So the slope that's the slope here. if I wanted a perpendicular slope, I have to flip 1 over. So I get 1 over 1 and change the sign, which then equates to -1. So, is this a negative slope on this line? No, I have to set it equal to y. I have to add it. So what's the slope of this line here? It's 1. So these are actual parallels. So this one has to be false.
False slope.
Okay, so drag it to make it false.
No, let's see yourself.
Wait.
You know, one more.
What's the last one say?
The vertical line is parallel to the y-axis.
Vertical is what to the y-axis?
Parallel.
Parallel to y-axis. Okay? X-axis, y-axis. Is a vertical line parallel? Is a vertical line parallel to this?
Yes.
So that must be true. Yeah.
Could you go back to the other?
So x1, y1, x2, y2. Plug them in.
Me too.
So 0 minus minus 2, so 0 plus 2.
No.
1 minus
All right, are we on to the next problem? Is that problem done?
No.
Was there one more?
There's like
Oh.
that problem was done.
That's
I
the
see.
problem
I
done?
thought it's in parallel. That's why. There we go.
Okay, are you into the next problem?
Oh. That makes more sense now.
Is this the next problem, Judge? Yeah. So we have this. I think most of you can handle this without too much trouble. And it looks like we're just trying to select the correct problem. How should I go about this problem? What's the process? Distribute the 3 here, and then distribute the negative here. So if I distribute the 3, I get -12x squared plus 24x minus 2x squared plus 7x plus 3. Is that right? Is there like terms I can combine?
Yes.
Yeah, I have a like term here and here, so that gives me -14x squared. Still with me? Is there a like term here and here?
Yep.
That gives me what? Plus 31x?
Yep.
And then I have a plus 3 that comes along. So figure out the problem. Is it written in descending order? I don't know what the answers are.
Negative 14x squared
Yeah, it
plus
is.
17x plus 3. Negative 10x squared plus 17x minus 3. Negative 10x squared plus 31x minus 3. And then negative 14x squared plus 31x plus
Sounds like the last one on yours.
Last one on mine too.
Okay, cool. We got another problem?
Yeah.
Are we moved up? Hey, did you move up yet?
Yeah.
Cool.
Oh, I remember this.
All right, these, we want to simplify each of the equations. So you're dragging the appropriate problem. So that's the first one. Second one, we have this. And then the third one is this. So you're dragging it. It looks like you have 3 problems, but you have a lot more answers. So you're not going to use all the answers, correct? Okay, so let's figure out this first problem. If I distribute that here and here, that's going to give me root 90 plus root 10. Is that okay so far? There might be a perfect square. Yeah, you have to think that root 90 might be able to be broken down to 9 times 10. And the reason I'm using 9 is the largest perfect square that goes into 90. You know, other perfect squares that are bigger than 9. 16 doesn't go into 90. 25 doesn't go into 90. 36 doesn't. 49 doesn't. 64 doesn't. 81 doesn't. So if I have this, what's the square to 9?
3.
So I get 3 square root 10. Yes?
Yeah.
Plus, what's in front of here? A 1. Are these like terms?
Yeah.
So can I add them?
Yes.
So I get 4 square root 10, and there's our answer.
Is this all on our test?
No, these are just samples. I have not seen the actual test. We will eventually take it. We will make it worth a score, but the nice thing is it's going to probably become extra credit score. Cool? So it's in your best interest to do the best you can on it, but if you don't, it's not going to destroy your grade. whatever you get on it should help your grade. Cool? So that's the first one. What about this one? I'm going to distribute here and here. What is 3 times 72?
216.
Bingo.
Is it what?
216.
216? 216? Sweet. Minus 3 root 6. Is that okay? Is square root 216 a perfect square?
We don't know that.
I don't know. But things that I might know is let's break 216 down. Okay? 216, I know that 2 will go into it. 108. Okay, that's not a perfect square, but if I find another 2, so now this 2 is going to go into it 54 times. So that gives me a perfect square. And then 2 goes into 54 27 times. So this 2 has to stay back inside. 3 goes into 27 9 times. And then 3 and 3. So let's think about what 216 breaks down to. It breaks down to 2 times 2 times 2 times 3 times 3 times 3. Okay? Can I break 6 down? I don't know. This won't break down anymore, so let's just leave it like this for now. What am I looking for on this problem?
Factors.
Okay, I have those 2 and those 2. So what is going to be outside? 6, a 2 and a 3. So it's a 6 outside. What's left inside? 6, because you have that 2 and 3 still left there. And then look at this. Do I have like terms?
Yes.
So I get 3 square root 6 for that answer. Okay? Third problem, going to be done the same way. We're going to distribute here and here. So I get root 15 minus root, oh shoot, root 75. Well, I know that it's going to be this. So let's not worry about multiplying it out because we know we're going to have to break it down. So 5 won't break down any further, but 75 will. Let's see, 75 breaks down to 5 times what? 1. How many?
15.
15? That breaks down to 5 and 3. So this root 15 won't break down any further. Minus this first 5. And then 75 is 5 times 3, right? Okay. So that 15 doesn't break down, but this does. What comes outside on that?
5.
5? Cool. All right, so I had root 15 stays alone. Minus 5. What stays inside?
15.
Root 15. 1 root 15 minus 5 root 15. 1 minus 5 is? Negative 4 root 15. Okay, so there's your answers. Was there one more? Joe, did you get there? Cool. All right. What number can be? So we have input and output. It looks like I have negative 13, negative 15, 20, negative 11, 0, negative 9, negative 4, negative 2, 11, negative 1, negative 1, 5, 17, 5, and then we have a 13. So we want to figure out what would go there. Okay, so input versus output. That's like saying your x value and your y values. These are like points. So a couple ways we could probably go about this problem. Excuse me. Let's see. Maybe we could rearrange. Yeah, what do you think? Slope? Let's do that. That's not like a good idea. Let's find the slope of these 2 points. Okay, and we know slope is this. So what I'm going to do is my output. So I have x1 or x2, x1. Or excuse me. These are y's. Sorry, I've been out of the classroom for 2 days, so I can't remember how to teach. All right, so let's figure that out. So I have what? Negative 11 minus negative 15. I did? That's a 2? Oh, shoot. That must have bumped my head a little harder than I thought. All right. So negative 11 plus 15 over 20 plus 13 equals, was that 4 over 33? Okay, so that's the slope. So I'm pretty sure that's the slope we want to get to. So now let's do this. Let's find the slope here. I'm pretty sure the slope has to be the same. So I'm going to use my slope equation again, but I'm going to have an unknown value. So I'm going to go x1, x2, or 2, y1, y2. So I know that, let's see, y2 is 13 minus 5, and then unknown, I'm just going to call that x, minus 17. What should our slope equal? What should our slope equal? 4 over 33. Okay? So let's see if we can figure this out. So I have 4 over 33, or 33. Geez, I'll tell you, I truly did take a bad fall or something. All right, so let me ask you all this. How do I solve when I have a fraction equals a fraction? What's our favorite term that we use? And then some math teachers say, no, that's wrong. Cross multiplication, remember that? So I multiply this times that, so I get 4 times x minus 17, and 8 times 33. All right, distribute here, so I get 4. Let's see, 4x, thank you. Jeez, you guys, I'm so glad you're here. I'm not. 34, 6 minus 68, good.
There we go.
And then 8 times 33, 24, 32, 264. Okay, let's extend our screen. Add 68. 4x is equal to what? 332. Divide by 4. X is equal to 83. All right, I'll go with that. Is that a drag answer? Is that on there?
No.
Oh.
You have -5, -1, 0, 2, 11, 17.
We're just a little off.
All right,
You just try out.
pick 5. Pick
Just
one.
take a minute,
Just pick one.
Just pick one.
Just select them all.
Select them all.
Oh, you can click more than one.
You can pick.
I'm gonna click all of them because then you're gonna get one of them.
Just pick all of them.
Sweet.
Damn.
All right, as soon as you're done with that, hit submit.
Oh.
And then once you've hit submit, log off your Chromebook,
See if I got it right.
put it back in the appropriate location in the cupboard plugged in, please.
Wait, when do you know when you're gonna get it?
They don't tell you when it's done. It doesn't show you. I know, right?
And then while you are starting to get your stuff back put away, thank you for doing that for me. That was just showing you how you will have to drag answers or click answers.
Crazy.
So if you would, let's get out page 113, 114, please. This is what I'd asked that you do on the sub day. If you didn't do it, well, it is what it is.
She said it was do it if you have it.
She said we gotta do one.
All right, it was actually just 113.
Never submit.
Yeah, she said do.
Oh, good. We will then do it together. Not a big deal. I know sub days get goofed up, so it's,
Well, we're skipping like 5
Yeah, what were we supposed to do? Yeah, no. We were not.
Was this something we had done? Okay. Okay. So also what I need you to do is page 99, 100, 101, 102. Let's have you all go ahead and put your name on that, on both sheets, and turn it in. If you're turning anything else in, go ahead and pass that forward as well, please. So, if you don't have these with you, then get them done over the weekend and turn them in on Monday. But if you have those, so page 99, 100, page 101, 102. Gianna, is that right? Did I say that right? Cool.
Did I say it right?
And then have page 113 out because I want to go through that, okay? Make sure your name's on both of them unless they're stapled. Please. Right here. I'll take him. Thanks, Diana. That's perfect. That works for me.
Sorry. I had to make sure my name was on it.
I got you. Like, no, don't take it.
Wait, aren't they seniors now today?
Defense was games,
Nope.
Jamie.
They got a few more days. Plus, we don't have any seniors in here, so. I know John looks like a senior, but he's not. Right, John? Thank you.
Oh, wait, I didn't even put mine.
Nope, you're good. Nice and clear. Thanks, Wyatt. Any more being turned in that I'm forgetting? Did anyone have it at the front of the row that I forgot? Joe's coming. All right. So, again, guys and girls, I asked you to please get out page 113. There's a single side. And let's just talk about them. Well, let's go through it. Let's make it work. So I'm going to do the problems. This is from page 113. So the first one we have. Thank you. Yeah. 113?
No. You go right to
Find it in the pile and then just put the pile back on here. All right. Few things. What kind of equation is this?
Linear.
It's linear. It's a straight line. So if I were to graph this, what's my first point I should plot?
Negative 4.
0, negative 4. That's our y-intercept, correct? So negative 4 is down here. 1, 2, 3, 4. What a dot. Everyone with me? The slope is like a map that finds another point. So I'm going to count from our point we found. I'm going to go up 2, and then I'm going to go over 3. Right? And all you need is 2 points to define a straight line. And there you go. Okay? Cool? All right, problem number 2. Problem number 2. Does everyone agree that problem number 2 is not linear? Does everybody understand why it's not linear? Yeah, we have an exponent that happens to be a variable. Okay? So this is an exponential equation. So a lot of times when you look at this, it's not real clear how to graph it. So let's think about what would happen if I made a t-table of like 3 points. So maybe we pick -1, maybe we pick 0, maybe we pick 1. 3 points might be good to give us a pretty good direction of what this graph is doing. Okay? I know that this 3 right here is actually shifting the whole graph up from what it would have done. But let's do the little math. So I have -2 to -1 plus 3. What is 2 to the -1 equal to? Not negative. It's not negative. No, not positive 2.
2.
This means it's unhalf.
1/2.
Almost 1/4.
1/2.
It's 1/2. Good.
What?
Okay. Remember, this is if you made this a fraction, this is unhappy. It wants to move down, right? So that gives me 1/2 plus 3. 1/2 plus 3 is 3 1/2. Is that okay? All right. So next part. Next part. I have. Oh, we have that negative here too. So that's negative here. Oops, man! I tell you, I wish I didn't hit my head. So it was a negative, right? So it was -1/2. So -1 plus 3 is 2 1/2. Remember, because that was a negative here.
Negative and negative equals
Also-
No. Those are not. This is a negative base. A negative exponent does not mean it's a sign negative. All right. Next one. Negative 2 to the 0 power plus 3. So what would 2 to the 0 power be?
Zero.
No, it's 1.
What
And
the-
then so I have negative 1. Anything to the 0 power, other than 0 is 1. Okay? So why does it stay negative though? Because the 2 is raised to the 0, not the negative 2. All right? So I get negative 1 plus 3, which is 2. All right, now let's plug 1 in. I get negative 2 to the first power plus 3. Negative 2 to the first is?
1.
Negative 2. Oh, man, you guys are off. I know I'm off too, but you guys.
I'll send the answer.
It is a Friday. All right, so negative 1, 2 1/2. Right? 0, 2, 1, 1.
Is it supposed to curve?
Yes. So that's, this would, I got a hiccup.
Bless you.
All right, so question for you. As my graph goes to the right, remember an exponential function has something called an asymptote. That asymptote is whatever we add or subtract. If there's nothing there, it has to be the axis. So going to the left, this approaches 3, that there. As I go this way, I'm going away from it. So I'm growing in the negative direction. So this is an exponential growth because as I go to the right, it's going away. It happens to be growing towards the negative, but this is an exponential growth graph. Okay? If this graph had done like this, it would be a decay graph because you're approaching an asymptote as you go to the right. Yeah.
If the exponent was -2, how do you do it? Can you just do it? If the
Say what?
x, so if the x was a -2, what would you do?
If the x was a -2. So it'd be negative, it would be 1 over 2, -2 squared, which is negative 1/4. So it gets closer and closer and closer. All right, number 3 is what type of equation?
Exponential.
Number 3 is what kind of equation? I will say it's not exponential. That was number 2.
Quadratic.
It's quadratic. So this forms what kind of graph?
Parabola.
Parabola. A curved one. Good.
You.
Oh.
All right. So if we look at this, my b value is 0. So my vertex is actually here. Does this open up or down?
Up.
Up. And I'm going to go right 1, up 1, left 1, up 1. I'm going to go right 1, up 1, 2, 3. I'm going to go left 1, up 1, 2, 3. So this is our parabola. This is the unit we were just worked on. What can you tell me about my roots?
Irrational.
They are irrational. Irrational. Okay. My axis of symmetry is right there.
I have a question.
Talk to me.
So if it doesn't cross the y-axis, would it be irrational? Like if it was shifted to
They will always cross the y-axis. Sometimes they will cross way off our graph.
so then if you can't visibly see it on the graph, what would you put?
Well,
That's
answers I accepted on your guys' quiz were, like, I think John had put this on a couple. It graphs way off the graph as the y-axis, and I accepted that.
I put it
Wait, will we have the quiz grades today?
I will have them done by the end of next period.
I put the answers down.
No, irrational is not the right answer because it will cross.
But you just don't know the exact.
Yeah. There's ways that we can find it, but all right, moving down our thing. All right, let's see. For each representation of a function, determine if it's linear, quadratic, or exponential. If linear, identify the y-intercept and slope. If quadratic, identify the vertex. If exponential, identify its y-intercept and equation of its horizontal asymptote. Okay, so problem number 4, we have y equals -8 plus, or negative that. Number 5, we have 4, or y equals 4 times 3 raised to the x. Number 6 is y equals 2x minus 5. And number 7, we have y equals x squared plus 3. So these are going across. So this first one is linear, quadratic, or exponential? Linear. Okay. Second one, linear, exponential, or quadratic? Exponential, because the exponent is the letter. Number 6, linear, exponential, or quadratic? Linear. Number 7, linear, exponential, or quadratic? Cool. Does everyone feel okay with that? It says if it's linear, identify the y-intercept and the slope. Well, the y-intercept is my b value, so it's 0, 8. My slope is what? Negative 1. Let's go to the other linear. What is my y-intercept of this linear one? 0, negative 5, and my slope? 2. Cool? All right. If it's a quadratic, find the vertex. Okay, the vertex, I have negative b over 2a. What's my b value? It's a 0, so I have a 0 here. How do I find the y component? Plug it back in. 0 squared is 0. 0 plus 3 is 3. That's my vertex. And what else do we need to find? Identify vertex is all we have to do. If it's exponential, find where it crosses the y-axis. So if I want to see where it crosses the y-axis, it's going to put a 0 in. It's x. Excuse me. I'm sorry. Oh man, come on, eraser. You got to work on me. All right. So if I plug 0 in for x, 3 to the 0 power is 1. 1 times 4 is
4.
There's where that happens. Is this? I'm adding 0 here. There's nothing there. So that is my horizontal asymptote is the line y equals 0. Okay? It's a horizontal line.
It's right there, bro.
Where? Oh. Oh, okay.
What's the symbol for this?
Asymptote, it's just this. It's just a horizontal line like that. So there's 3 different types of asymptote. There's horizontal, there's vertical, which you get to in Algebra 2. And also in Algebra 2, you'll get to something called a slant asymptote, which is also sometimes called an end behavior asymptote, which you use synthetic division or long division to get to. It's pretty cool.
How am I going to get through Algebra 2?
Algebra 2 is a good one. All right, so let's see. I'd say this is definitely linear. What do you think?
It is definitely linear.
And if it was linear, we have to figure out where does it cross the y-axis.
0,1.
So at 0, axis at 0, 1, good. And then we need to define the slope. Okay, negative 3 minus, and negative 1 minus 2. So that's 4 over 1. So that's my slope. Number 9, what do you think?
Oh, this is exponential.
Yeah, they gave us this graph that's doing this, right? That's exponential. Where is it crossing the y-axis does it appear?
0,4.
So it's crossing at 0, 4 for the y-axis. What line does it appear that it won't cross down here? Y equals 3. Good. Okay. Number 10, linear? Linear. So if number 10 is linear, where does it cross the y-axis? 0, -4. Awesome. The slope of that would be, looks like it goes up 4, right 6. It's not quite up 1 over 1. Right. So I think up, so let's go up 1, 2, and then over 3. Up 2, right 3. Slope up 2, right 3. So slope is 2 over 3. Yes? Number 11. Pretty sure it's a Quadratic. So it's a quad. We want to just find if it's a quadratic what? The vertex. What's the vertex?
1, -4.
It's 1, -4. That point right there. Cool. The function is increasing at a constant rate. What increases at a constant rate? Linear. The slope is always the same. The population of bacteria starts at 10 and is doubling every hour. It's exponential, right?
Yeah.
And an employee increases your salary $1 every week.
Linear. Linear.
So the slope stays the same, right? So it's linear.
Linear.
Linear. All right. So, guys and girls, and children of all ages, I would like you to work on. This is just review of you know what it is.
You know what it is.
So I would like you to work on page 115. Is there 116 to it? Yep. Page 115, 116. Okay? So a few things. I was going to do this today, but I decided not to because it was goofy. So what I'm going to do is on Monday, we will go over this, and I'm going to give you the take-home test on Monday. Okay? Got it? So you'll have the period to work on it. Remember, how's the take-home test going to work?
You can use anything but you.
All but me, right?
All good.
And then on Tuesday next week, we will have our actual test. I know, it got goofy. We've been reviewing a lot. So this will be due on Monday. I will go over this whole thing if you need me to. And I tell you what, why don't I just check this off on Monday at your desk so you can use it as part, you can use it to help you on the take-home test. Cool?
Cool.
Everyone feel okay? Everyone with me?
Awesome.
Woo! Hey, dudes and gals and guys and peoples, I'm so happy to be back. Hope all is well.